show you some cases for incident rays. Means if we are taking spherical mirror, it may be concave or convex. If incident ray have different positions, means incident ray is incident with different cases, then how it is reflected, that we will discuss here. Now let us move. In the first case, if we are taking our incident ray is parallel to principal axis. So let's see. In the first case, it is incident rays parallel to principal axis. Now you can see we will talk this for both the lenses, both the mirrors, concave mirror and convex mirror. Now firstly I have my concave mirror. This is principal axis. Now we are talking about the incident ray which is parallel to principal axis. So suppose this is my pole, this is my principal focus, and this is my center of curvature. Now let us draw incident ray parallel to principal axis. So here the point is that how will it get reflected? So you will observe that this ray will get reflected by passing through the principal focus. This is not only the case for concave lens, it is also applicable for convex lens. Let us see how. Now here again I am taking convex lens here. This is my pole P, this is my point, that is principal focus, this is center of curvature. Now in this case again our incident ray is parallel to principal axis, you can see. Then you will see that now in the case of convex lens, your focus is on opposite side. So here you will see that reflected ray appears to be emerged from focus like this. It will be reflected, it will be reflected in the same side, but it is appeared that whether it is emerges from the focus. So this is the case for convex lens. So here you can see, if I am telling you this, attention, if the incident ray is passing parallel to the spherical mirror, then it gets reflected from the principal focus of the mirror. So here I will write reflected ray passes through F, that is principal focus. Now let us move to our next case, second case. Now if the incident ray is passing through focus but it is obliquely incidenting, means I will show you. Means we are taking opposite of this. In the first case ray was parallel but passing through focus. Now here we are taking incident ray is already passing through focus. So passing through focus, that is F. So here again, okay, firstly I will show you for convex lens, or let us take concave lens only. So firstly I have concave lens. This is your principal axis, this is pole, this is focus, principal focus, and this is center of curvature. Now condition is that your incident ray is passing through focus. So like this you can see, this is my incident ray which is passing through principal focus. Now you will observe that it will get reflected like this. Means it will get reflected in the same side, but in the same medium, but the ray, reflected ray, will be parallel to the principal axis. Now similar case is applicable for convex lens also. So let us draw one convex lens here. This is your principal axis, pole, then now again for the case of convex lens, your focus is from, this focus is at different side of incident sides. So what you will do, you will draw the incident ray such that it appears to be passing through the focus like this. You can see, suppose this is point O, means point of incident is O, but it appears that whether it is passing through focus F. Now you will see that this ray also will get reflected like this. Means you can see it is parallel to principal axis. So this is the case. So here we will write reflected ray is parallel to principal axis. For our convenience, we can write the principal axis, as x dash here. So reflected ray is parallel to principal axis, which is x dash. Now let us consider the third case. It is C case, when incident ray is incidenting obliquely, but it is passing through the center of curvature of the mirror. Means oblique ray passing through C, that is center of curvature. Now again let us take concave lens. Here is your principal axis. This is your center of curvature C. This is your point, that is principal focus. Now condition is that your ray is incidenting obliquely and it is passing through C, that is center of curvature, means like this. Now if you will perform this experiment practically, if you will do this, you will observe that this incident ray is reflected back along the same path. Means incident ray and reflected ray are same here. Means your reflected ray is passing by the same route of the incident ray. So this is the case for concave mirror. Now let us see what happened with the convex mirror. Principal axis, focus and center of curvature. Again same thing, means incident ray lies on another different side and curvature also lies on different side. Means both are lying on either side. So what you will do, you will take incident ray like if it is passing through center of curvature like this. Okay. Now you will observe that means your incident ray is in the direction of C, but you will observe that it will get back reflected. Means reflected ray is traveling by the same route of incident ray. So here we will write reflected ray passes with the same route of incident ray. Now you must be thinking why I am drawing all this. Actually, next part we have to draw the diagrams of having position, means we will change the position of the object by taking concave and convex lenses, and accordingly by passing the rays we will observe that how images form and how far images form. That you will understand in the next part. Now here our next case is your incident ray, means incident ray is in the oblique direction. It means it is incidenting obliquely, but it is passing through pole of the mirror. Means passing through P. So here again we have concave mirror. Here is your principal axis. Here is your focus and center of curvature. Now according to a given condition, this is your incident ray making angle I. So it is incidenting at point P. So you will observe that it will reflect like this by making angle of reflection R. And you will observe that angle of means angle of incidence is equal to angle of reflection. Similarly, for convex lens, it is very simple here. Again your incident ray is oblique and it is passing through pole, so it will get reflected like this. So this is your angle of incidence I and this is your angle of reflection R. So here we have studied the different cases for which incident rays have different directions, and accordingly we get the reflected rays. In the first case, incident rays was parallel and reflected ray was passing through focus. Second case of opposite of first case, incident ray was passing through focus and we get the reflected ray parallel to the principal axis. In the third case, our incident ray was passing through the center of curvature and it was back reflected. And in the fourth case, incident ray is oblique and it is passing through the pole, and in this way it gets reflected by making angle of incident is equal to angle of reflection. So actually in all cases, if you will observe, angle of incident is equal to angle of reflection. Definitely we are talking about reflection, so all the cases will follow the laws of reflection. So now here I would like to show you how angle of incidences are equal to angle of reflections. Here it was the angle of reflection, means angle of incidence, and this was the angle of reflection. In the second case also, I will not draw here, I will just explain you. Suppose this is your point A and yes, and this is P, and suppose this is C. So angle APC, suppose here you have B, is equal to angle CPB, means APC is angle of incidence and CPB is angle of reflection here. Now in the third case also same thing we have. Here you will see, means here if you talk about the angle of incidence and angle of reflection, you will see that both are 0 degree here, means both are passing through the center of the curvature, means angle of incidence is also 0, angle of reflection is also 0 degree here. And here is the simple example. Here I have explained you already how angle of incidence is formed and angle of reflection is formed. So let us move forward.
No more spending your energy and money on coaching classes or missing classes for rain, for rally and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
In this part, we will see image formation. In the last part, I had explained you how rays are reflected. Incident rays are reflected in what way. Now in this part, we will see how images formed by using concave lens. So we are studying image formation for concave mirror here. So now, one arrangement I am explaining you. This is very nice experiment that you can perform in the laboratory of your school. Here, firstly, you have to take one concave mirror and you have to find its focal length. By the way that I had explained you, that means you can capture the image of the sun or any light source which emits light, and you can obtain its image on the screen and measure the distance between the image and the mirror. So that will be your focal length. So here the arrangement is you have to take one stand On that, suppose this is my stand. On that stand, suppose I'm arranging my concave lens here, and here is my focus, and here is the center of the curvature. Now here we will adjust suppose this is my screen, and in this part, in the left hand side part, we will put our object. Screen can be rotated by the condition of the image formation. Here in the case of concave lenses, mostly you get the image of the object on same side. So here the first condition is, means you can perform this experiment. Suppose you are placing one candle here, and accordingly you will observe the formation of image of the candle, and that you can observe by putting screen somewhere here. So this diagram I have drawn just for the sake of understanding how the experimental setup will be. You have to place one concave mirror, then you have to fix its point of focus and point of curvature accordingly, draw line at those points, and then put one candle, and now we will perform the experiment. How we will perform? Firstly, you will put candle very at very larger distance. We can consider that distance as infinity, and accordingly you will observe the image. First case. In the second case, you will put your candle just beyond the center of curvature. That means you will decrease the distance between candle and the center of curvature. And observe the image obviously. And in the third case, you will put your candle at the center of the curvature. In the fourth case, between C and F. In the next case, at F, and in the next case, between F and P. Means we are performing this experiment by changing our position of object, and accordingly we will note down the quality of the image, distance of the image and all. So let us study those cases. So here the first case that we have, we will put our object at the distance infinity from the mirror. Means object position is at infinity. So object is kept at infinity. So how the image will form? Let us discuss here. So now here is our concave lens. This is the principal axis with pole P. Now here suppose this is the object. I will name it as A, B, and this is at infinity obviously. So definitely the rays from the object will come parallel like this, right? So suppose here is your focus of the lens and here is center of the curvature. After reflection of these rays, you will observe that both the incident rays, if you remember the first case that I have shown how parallel rays get deflected, if you remember, parallel rays means parallel rays to the principal axis get reflected by passing through the focus, that is principal focus. So this will get reflected, these two rays will get reflected like this. So you will get the image at the focus. So this is the first case. In the second case, now we are putting our object just beyond the point of curvature. Object, it is beyond C, means the distance between the object and C is finite here. Firstly it was infinite. So again we have the, okay, we have to take concave lens here, we are not talking about convex lens. Then let us draw principal axis with pole P, focus F, center of curvature C. Here, if you are drawing these figures in your notebook, make sure that CF is equal to FP. Then only you will get the correct ray diagram. Otherwise, your figure would be wrong. So, this is your center of curvature and this is the focus. Now here, suppose this is the position of the object. It is A, B. Then how rays will travel? One ray will come from A. It will be parallel to principal axis, and one ray, it will be traveling through your center of curvature like this, and it will get reflected. So as you know, parallel ray will go through F like this, and the ray which is passing through center of curvature will be back reflected. So you can see there is a space between principal axis and the point of incidence of these two rays. So here is your image, means this last point is A dash and here is your B dash, means here AB is the object and A dash B dash is my image, and you can see image is inverted downward. Why downward? I am saying ray coming from A is reflected in the downward direction. That's why A dash is below B point, means B dash point. So here you can see my image is image is inverted here, and AB was straight and A dash B dash is inverted here. So this was the second case. Now let us move toward the next case. In this case, we are putting our object at point C, that is center of the curvature. Again, let us take concave mirror. this is your principal axis, here is your focus, and here is your center of curvature. Now according to our condition, we are putting our object at point C. So this is my object A, B. So again similar thing, a ray coming from A, first ray will come, means first ray will pass parallel and second ray will pass through focus. And as you know, the ray which is travelling parallel to the principal axis will get reflected from focus like this, and the ray which is passing from the focus will get reflected in the direction parallel to the principal axis like this. So you will see that the point of incidence of the two axis, reflected rays is here. So which is at the approximately here, I am not taking exactly calculated distance, so a little bit change will be there, but if you are drawing in your notebook, you will take the distances perfectly, so you will get the perfect image there. So here you will see that I will get the image at the same point where the object is placed, but the image again is inverted here. So I will get image as B dash A dash, means B dash is on upper side and A dash is on the downward side. So this is the case, third case, where my object was placed at C, that is center of the curvature. Now in the next case, again we will move our object towards the point, that is towards the pole of the mirror. Now we will put our object between C and F. Now pay attention here. It is our fourth case. Object placed between C and F, that is between the center of curvature and the principal focus. So again I have concave mirror. This is your principal axis. Okay, now I will take the points. It is focus and this is center of curvature. Now we are putting our object at point between C and F. So suppose this is my object A, B. Now one ray will travel parallel to principal axis as written on all cases, and here you will say that this you can see that one ray will travel like this. Means whether it is passing through the center of the curvature, and after reflection definitely the ray which is parallel will passes through focus. like this, and another ray which is passing through center of curvature is back reflected, that you know. So now you can see I am getting one point of coincidence due to these two reflected rays which is here. So if you will join it with your principal axis, you will get the image. Again it is inverted image, but you can see size of the object was lesser, my image is greater in size, and it is inverted here. Now in the fifth case, we will move our position of the object on F, means we will put our object at point F here. So object is placed at principal focus. So again, this is my concave mirror, principal axis, focus, curvature of the center. Now we are putting our image at point F, so it is AB. Now one ray will travel parallel to principal axis, and similarly another ray will travel through center of curvature like this, and also it will get back reflected. Now ray which is parallel will come back from the focus. So now you can see these two rays are parallel to each other. That means our image will form at infinity distance. Means we will not get image at finite distance. Means we can't see the image here. So this was our fifth case. Means if we are putting our object at F, that is at focus, then our image will be at infinity. Means in this experiment, suppose I put my candle here, what will happen? Image will be formed at infinity distance, that we can't see here. Now in the next case, we will put our object between focus and pole. So let us see. Object we are putting between F and P, that is focus and pole. So here I have concave mirror again. This is the principal axis, this is point pole of the mirror, this is suppose focus, and this is your center of curvature C. Now this is my object between pole and focus. So here you can say one ray will incident at pole like this, and another ray again it will pass through center of curvature like this. So one ray which is incident at pole P will be reflected like this, that we had studied in the fourth case, and one ray which is incident at center of curvature will get backscattered. Now you can see these two rays are going apart, means reflected rays are going apart from each other, means we will not get our image on the same side of incident rays. But look at this, if you will increase the rays here on the back side, reflected rays you are extending on back side, you will get one image here. So you can see this image will form inside the mirror. So this image is virtual, means this is not the real image because it is forming inside the mirror, and also this will be greater in size. So that's why when we are looking at the concave mirror, the image is inside and also the size of the mirror, the size of the image is wider. So now in the next part we will write it in proper ways. Now here total we have studied 6 cases, means putting object at different places. Now I will just revise the thing. In the first case you can see our image was beyond the center of curvature, means it was at infinity. So the image we got at point F, that is at the focus, then it was highly diminished point size image, means that was very little point, you can't see the means we know that image is there but there is no particular bigger size, and here the image is real and it is inverted. In the second case we had object at finite distance from the center of the curvature. So in this case what we have find, the image was formed between the center of curvature C and point of focus P, F. Then image was diminished but it was real and again inverted. In the third case, here object was at point C, image also we got at point C only, image was image of the same size and it was real and inverted. Then in the fourth case, image was enlarged when the object was between C and F, that is center of the curvature and the focus, but image was of the larger size, enlarged image, but it was inverted. Then at the fifth case, when we are putting object at the focus, that is principal focus of the lens, image formed at the infinity and it was highly enlarged, definitely it is at infinity so it will be highly enlarged, and it was real and inverted. Then again in the last case, we are putting our object between F, that is focus, and pole, that is P. Then we got the image behind the mirror, inside the mirror we can say it is enlarged, it is virtual and erect, means it is not inverted, it is a straight image, erect image, but it is virtual, means it is not the real image. So we will tabulate this in a table so that it will be easy to remember.